Okay, lesson we're going to talk about graphing linear equations. And again, I'm not going to be able to get into a lot of detail. This is the kind of thing we could do, 10 examples, and then you'd need to do some practice. So I'm going to show you two major types of the major form you're going to see before you graph a line. And hopefully this will get you a little head start on understanding this better. Okay, let's start with this equation. Y equals 2/3 x minus 1. This is in the y equals mx plus b form, which you're probably most comfortable with, I would assume. Where m, recall, is the slope, and b is the y-intercept. And x and y are the variables, so as x changes, y changes. X being the independent variable, y being the dependent variable. So if you know the slope and the y-intercept, you probably are familiar with this technique. Bear with me while I draw this. That's probably good enough. So the y-intercept is the thing you typically plot first. So I'm going to go down to -1 and put a dot. Y-intercept means where the graph hits the y-axis. Intercepts, kind of meaning hits, or intersects even. Then use your slope, and your slope, hopefully you recall, is rise over run, which is a pretty good way to remember. The main thing is that rising is a vertical motion, running is something you do on a horizontal surface typically. I guess you could run up or downhill, but typically you're running horizontally and you rise like steam rises vertically. So do the vertical part first. So 2/3 means it's going to rise 2. So if I go up 1 from -1, I hit the origin. Up 1 again, I'm at 0, 1. And then it's going to run 3. So I'll go over 3. 1, 2, 3. This is kind of a crude graph here. Now, a point or 2 or 3 or 10 is not graphing. You need to actually draw a line. Ruler is great, but I'm just going to do my best on this iPad here to connect the lines, and that's actually pretty good. I like for your line to cover the whole space of the graph area over the XY plane. Let's put those on there. It's a lot of times people do these kind of little graphs. I want to see where it's going to go. I don't want to just see a tiny little sample. Show me it passing through the whole region, and that would be good enough. I see 2 points clearly marked, 0, -1, and 3, 1. It's a pretty good graph there. Let's do it one more. Okay, the last one we did was in that y equals mx plus b form. This one is going to be in what's often called the ax plus by equals c form, which maybe you're not as familiar with. Ax plus by equals c. Sometimes this is called standard form, although that's a pretty generic term, and I've heard some people use standard for the slope-intercept form, which is y equals mx plus b. Technically, this is a standard form, but I know that word is kind of not the clearest, so I just call it ax plus by equals c form. When you're in this form, you could solve for y. We talked about doing that in I think the 4th lesson, where you subtract 3x, you divide by -4, you'd have a big messy equation. It wouldn't be that bad. You could do it. But I want to show you another technique, and this is one where you plot it by its intercepts, which is actually probably the most ideal way to graph, is because people often want to know the intercepts, and so we're going to find them out. What I do first is, maybe off to the side, make a little tiny XY table. It only has to be 2 rows tall. One of them, I'm going to put a 0 in for x, and the second row I'll put a 0 in for y. And so I'm going to say, what happens to y when x is 0? Now, I wish I could show this to you, but I can't. You might cover up on your screen the 3x, because if x is 0, 3x is 0, right? So cover up 3x, and now you have -4y equals 12 remaining. Let's solve that. This is a little bit working in your head, but if you solve that, you divide both sides by -4 and you get -3 for y. Okay? What if y were 0? Now, cover up if y were 0, -4y is going to be 0. The whole thing's going to go to 0. So if you cover up the -4y with your thumb or something, you just have 3x equals 12 remaining. So solve that one in your head. Divide both sides by 3 and you would get +4. So what those are, these are actually coordinates I now know are on the graph. You don't have to write what I'm writing here. This may be obvious to you, but these are coordinates on the graph. So let's graph this. So if I went down, oh, that's not very good, is it? Should be a little more straight than that. If I go down 3, put a dot. I go over to the right 4 and put a dot. And then you only need 2 points to be enough for a line, so connect the dots. Make your line extend out so it kind of goes through the entire region. You're done. Yes, you could have solved that for y in case you were curious what you would get. If you solve this for y, I'm just going to kind of skip some steps here and not show my subtraction. I get that, right, by subtracting 3x on both sides. Now dividing by -4, I would have got +3/4 x minus 3. You can kind of see it's the same thing. -3 is a y-intercept. You go up 3/4, that's your other point. In a case like this, it wasn't that much different, but many times this technique is a lot easier. You make your little tiny XY table and you connect them, and that can be helpful. So hope this lesson helped. See you next time.
Made with Doodlecast Pro.